So today's topic is jets, toilet paper, and microchips for Techie Tuesday. So what do those have in common, and how do those play into the STEM world? So, our topics today we're going to cover is what is STEM really? What are the different, career paths for it, different ways to get into the STEM fields. And then we're going to talk a little bit about how does a concept become a product and tie that into why diversity is so key to that. And then we'll walk it through why do jets, toilet paper, and microchips all have in common. So moving to poll number 1. So this is what Kathy is talking about. If you guys can participate as these show up. What are the fields that you think are included in STEM careers? So when you're looking through these, select all that you think apply.
All right, go ahead. We're getting a few votes in. All right, I'm going to end the polling now and going to share the results.
So as you can see from the shared results, engineers, that was a quick, easy one to pick out. Chemist was an easy one to pick out. Most people picked astronomer or doctor. Architect got a lot of choices as well. However, some of these other ones got a little bit fewer, so such as like a welder or an HVAC technician. So we're going to move to the next slide, which is going to talk about actual STEM careers. So you guys were all right, but there's a lot more to STEM than maybe what some of you realized. So STEM careers aren't always the obvious ones you think about, the doctors and, and performing surgery, or the researchers doing the COVID vaccination, that type of stuff. Sometimes they can be a lot more as far as in the trades, or technicians, even pharmacy technicians, radiology technicians. Those are all STEM fields. So let's talk about the COVID virus and which of these STEM careers we think might be important right now towards making that vaccination. So as you just kind of look through some of these STEM careers, you'll notice that there's, a chemist, there's probably chemists, there's probably biologists, there's probably doctors and nurses involved. There might even be some pharmacists involved in doing this. Obviously some engineers, biological engineers, chemical engineers. And then as you look over at some of the other ones and you start thinking about it, what about the HVAC technician? What's his part in developing that vaccination? So when you think about where they're developing the vaccination, usually it's in a BSL 3 or 4 style lab. And those labs have to have very strict controls as far as temperature, ventilation, different humidity levels, stuff like that. So the HVAC guy goes in there and he sets all of that up, sets up the control system for it to set it up to a very specific environment. It's the exact same way at Micron. So when we're working in the fabrication area, we have to have very specific conditions. And so, we have to turn over the air 3 times an hour, different things like that. And so HVAC plays an important part in STEM and in making microchips as well. So then moving forward, how do you make that concept become a product? So a lot of people have really great ideas. You might have this one brilliant thought where you're like, oh, I have something that nobody's ever thought of. It could change the world. But there might be a problem with that brilliant thought. If you can't take it from a small test tube and make it into production worthy type product, you don't have a market to sell it in. So every time you have this brilliant thought, you have to be able to take it, scale it up, make it into a product, and then be able to, put it out to the marketplace. So another important part of putting it to the marketplace is you have to sell people on that concept as well. So when you look at that, there's a lot of STEM careers involved in this portion. So you have, the person that dreams it up. You have the person that develops a way to manufacture it. You have the person that brings up the yield and optimization on it. And then you have the people that do the finances on it, look at the accounting side of it, look at how to market it, how to put it in the marketplace. So these are just 3 pictures that kind of demonstrates that. You have the scientist working in the lab, you have the engineer dreaming up how to make it go into an actual product, and then on the far side of the screen, you have a picture of me actually when I was working on one of my other jobs, and we're working on yield and optimization. So here we were taking a wastewater sludge and turning it into a fertilizer. So we made a product out of something that should have been a waste stream. So what is diversity and how does that come into play in turning a product from a concept into the marketplace? So when you look at the manufacturing industries, Kathy gave me a fun fact yesterday. the profitability of a company can go up from 15 to 20% based off of the diversity within the group. So most people, when you think of diversity, you think of a couple things right off. You think about ethnic-based diversity, or you think about, male and females in the workforce. Those both play a key part in that because you bring in different concepts, different environments from home, different ways of thinking. But really, is it just that? You also have to think about how a person is raised. So when I was in my early 20s, I was working on a job, and I was working with a girl that was out of New York City. I grew up in small towns. I grew up in towns where you could drive at the age of 14 with a license. But she grew up in downtown New York. So when we were working, I asked her if she could go grab the keys for the work truck and go pick up a part. And she just gave me this blank stare back. And I couldn't understand why she wasn't willing to go take the truck. She said, I've never driven in my life. I've never had a license. So you think about that and how people approach problems differently. If you've never driven before, you're going to approach the problem differently than somebody that's driven on a farm for a good portion of their life. So how about hobbies? If you are a snowboarder versus a mountain biker, you bring different thoughts. Or let's say your hobby is playing music versus a sport. There's a lot of different concepts that you'll bring in, a lot of different thinking as well. Another part of it is, one thing I hear a lot doing some of these talks is that individuals worry about, what if I don't have the right brain for this? What about if I don't think the right way? So we did a study at Micron a few years back called Emergenetics. And these are 6 profiles of how people think from within a group that I worked in at that time. I obviously removed the names so that people don't know who they were. But they looked at different ways that you approach problems or that you approach people. And so the red sections are social. So you'll have a percentage for that. You'll have a percentage for analytical. So these are the people that traditionally you have to come to them with data. Here's my table, here's my graph, here's my facts, and then they'll be able to make a decision. And you have structural based people who need to have a framework. So you have to give them a box and say, this is the box that you're working in. You can work anywhere within this box, but this is where you need to stay. And then you have more conceptual thinkers that see the bigger picture. So sometimes those people struggle to stay in the box or to stay focused. So each of these have their positives and negatives as well. But this is what diversity in a workforce looks like. So when you look at these graphs, traditionally you'd think of social as a very female type trait, right? So if you look at the one up in the top corner with the 51% social, that was actually a male engineer. And then if you look at the very structural one right below that one was female. You have the quad, who's almost evenly divided between the 4. And the one right above it, those are both male engineers, but they think very differently. And then if you look at the other 2 on the far end, those are fairly similar, almost identical type graphs, and they're split between male and female from different parts of the country and different backgrounds as well. So there's not one brain that comes in, it can actually do a STEM job. There's a lot of different brains, even within the same STEM job, that do that work. So now we're going to get to the part about where jets, toilet paper, and microchips tie together. So what do these things all have in common? They're all different career paths that I've taken along my way. So one of the reasons I like to do these talks is that when I was in high school, I wasn't quite sure what I wanted to do. So I went into my guidance counselor's office and I was all excited because they said, hey, we had this test that we can test your aptitude and tell you what your best job would be. Thought, oh, that's perfect. I don't know what I want to do. They can tell me what I should go do, and then I just go do that. Works for me. So I went in there and I took the test, and I was extremely disappointed when they called me in to give me my results, and they said, oh, your aptitude fits a long list of jobs. You have lots of choices. You should be very excited. And I was not, because I wanted them to tell me what to go do. So when I got out of high school, I wasn't ready to go to college yet. And I wasn't sure what I wanted to do, but I did know I wanted to travel. So I ended up joining the Navy. So I went into the Navy. I became an aviation electronics technician, which is a STEM career because you have basically an associate's as an electronics technician. When I joined the Navy, I thought I wanted to go be a history major and become a lawyer somewhere, but very quickly I realized once I started working that I actually really enjoyed more of the hands-on work and seeing how things come together and how they function. So here's some fun plane facts. When I was working on the jets, mine are the kind of ugly looking ones right down here. They're called a prowler, and they're a radar jamming plane. You can actually put 3 of them off the East Coast. Well, they just decommissioned them a couple of years ago. But you could have put 3 of them off the East Coast, and it would have jammed all radio, radar, and satellite signals on the entire East Coast. So a pretty cool plane, one of the few that we never sold to foreign countries, actually. But one of the things that amazed me is working on a carrier. These jets will weigh somewhere between 55 to 75,000 pounds, and they take off in the space of a football field, so about 100-yard space. So you can see the F-14 here in the middle. You can see the afterburners all lit up as it's getting ready to take off. So just the sheer amount of engineering that went behind them to get those to be able to take off that deck in that short period of time amazed me. So after I got done there, I started going to school part-time, but I was still working as an electronics technician. So the one benefit of having a STEM career is that there's a lot of ability to move around. So I went to work in Nevada for a while in a ground-based radar system, and then I returned to Washington and worked on the same planes I was working on, but as a civilian contractor. During that time, I went back to school full-time. So I went down to Oregon State in Corvallis, Oregon, and started a chemical engineering degree. Some will ask why I didn't do electronics or electrical engineering. I honestly, when I started thinking about going back, I thought back to my high school days, and I had a very inspirational high school science teacher that taught chemistry. She was very passionate about it. She'd leap around the room and come up with these great, aha moments. And so I chose going back for chemical engineering because it seemed to make more sense to me than the electrical side. And I had that role model when I was growing up. So as I went through, I started working an internship at Georgia Pacific. So there was never a time in my life where I said, oh, I really want to go work pulp and paper. But I seriously enjoyed it after I got there. I'll be completely honest, I've never had a job I haven't enjoyed to some level. I just like seeing how things work. So right now, toilet paper is a key commodity. If you were to look at the price of a barrel of oil compared to a pack of a 4-roll of toilet paper, the toilet paper is more expensive. So, and if anybody's been out shopping recently, you know it's nowhere on the shelves. So some fun facts on paper making. The machines I worked on were similar to the one in that top diagram. And they were, pretty long machine, but at the same point it fit within one building. And you would take the pulp, so the paper fibers and water, from one end of the machine to the other end of the machine in 3 seconds. And so the pulp, when it came in on the front end of the machine, would come in at 0.3% fibers. When it came out on the other end in 3 seconds, you were then at about 96.5% fibers, and it was dry paper. When you touched it, it felt dry. Our machines that we had up there would make about a mile of paper a minute on a roll that you can see in that far bottom picture down here at the very corner, on a roll that was about 15 feet long and over 6 feet in diameter. So every 20 minutes, we would have one of those gigantic rolls come out that guy is standing next to. It's about 3,000 pounds of paper. And then we'd take it down and we'd ply it and make it into the much smaller rolls that you get in your bathroom, because the one that down there is obviously not going to fit. So you look at the store shelves right now and you wonder how they can be empty. We were considered a small mill, and we'd put out about 1.75 million rolls of toilet paper or paper towels every day. So poll number 2, when we talked earlier about how you took something from a concept to a product, you have to think about the characteristics that go into that. So you have to be able to market it and sell it to somebody. So when you look at toilet paper, what do you think makes it marketable? Look at maybe the differences that you'd have in the toilet paper in your house versus the toilet paper in a rest area. What are things that you see that are important?
We got almost 70% voted. Anyone last voting? And I'm going to close it now. I'm going to share the results.
All right, so we have quite a good grouping of results here. Softness is the winner. This is actually a key characteristic that a lot of people care about, and it's not one that can be easily tested with tools. We actually had a panel that had people that would hand test it compared to samples that we considered our reference rolls. So when you look at some of the others down here, absorbance is high. Everybody likes an absorbent toilet paper. Strength is also good. Tear strength at perforations isn't quite as high, but it's pretty far up there. So one of the key pieces here is that when you're in the bathroom and you give that toilet paper roll a good pull on it, you don't want the whole roll to come off and land on the floor. So it's actually a pretty important one. And they worked to develop a zippered type of format, so that way it would actually tear easier from one side to the other versus straight down. So Bear on the package got a few. So you're absolutely correct. This one is not extremely important as far as a characteristic of toilet paper, but it's an extremely important selling point when it goes to the market. So everybody loves the Charmin Bear commercials. So did you guys realize that much work went into making toilet paper? So this is just kind of a recap of, slide of those results. A couple of the other ones that are important is the ability to break down. Like when you look at people that take out their motorhomes and stuff like that in the summer, they want to be able to have a tissue that breaks down easily in liquid. So you saw how big that paper roll was. It was 15 feet long, over 6 feet in diameter. That guy sitting next to it looked really small and minuscule. Well, now we're going to talk about microchips and how small those are. So when talking about microchips, we don't even really talk about centimeters at all. So that's about the size of a bean. When we talk about millimeters, we really only talk about that as far as the diameter of the wafer. We don't talk about it as far as the size of any of the chip pieces. So you divide that up and you start looking at the size of a human hair. Very seldom will you hear anybody that makes a memory chip talk about 100 micron type sized feature. So you divide that again, you start talking about a micron. So even most of the things on the memory chips at the size of a bacterium are large. So that'd be considered, a big trench or something like that. So you divide that up and you get down to the size of a virus, so 100 nanometers. So on a microchip, we have features that are smaller than a virus. So when you think about how they talk about wearing a mask out in public, and if it's the cloth one that the virus could still get through, stuff like that. So think about how tiny those features have to be if it could get through the weave of the cloth. And then you get down into the nanometer, which is the size of a small molecule or a few atoms. And then you get down to the angstrom size. So most of our stuff falls, more the 100 nanometer type size, but we do have some that we put down at an almost atomic level. So here's some shots off the internet about microchip making. So just so you can kind of see the process side of it. You start out with the silicon wafer, and then you put down a mask, you trace a pattern into it, and then you build kind of a mini city on top of the wafer. So here's some pictures of kind of what that mini city looks like in a cross section. And then you look up at the top and you see those round wafers. So when you were younger, your parents always told you that you couldn't put the square peg in the round hole on that little box game, right? So when you're looking at these pictures, you wonder, why would you put rectangular chips onto a round wafer? There's obviously room to fit more if you made it to be rectangular or something like that. So there's a lot of reasons behind having a circular type wafer, but the key part is for putting down like photoresist and stuff like that. When you put on spin-on coatings, you have a dropper that just drops little drops at a time, and that wafer's spinning at 3,000 or 4,000 rotations per minute, so that it can fling that liquid across the wafer and make it uniform the whole way. Because if you drip too much, or if you spin too slow, you'll end up with bumpy parts of the wafer as it dries across the wafer. So poll number 3, what are some characteristics that we care about in memory?
And we're done. Share the results.
All right. Oh, we got a bunch tied at 90% this time, and good choices of options as well. So speed is obviously one, because when you want to find out some information, when you want to Google faster than your friend on your phone, you definitely want your phone to be the faster one, don't you? And then you start looking at the physical size. So that goes back to the phone or the application you're using it in. So if you use it in a, in a computer, you don't care if the memory is a little bit bigger. If it's in your phone, you don't want to be carrying around a computer up to your ear. And then the amount of storage and reliability, these are very important, because with the ease of taking digital photos now, everybody has gigabytes stored on their phone and their pictures. And reliability wise, same thing. So if you just look at pictures on your phone, you definitely don't want to lose all of that history, since you don't have them printed out anymore. And then the M on the top, well, we care about that because they're Micron. So to us, that's extremely important, but it might not be to everybody when they're picking a chip.
And Sarah, you want to mention what that picture is behind you?
Oh, yes. The picture behind me is actually the Boise campus. So this is the Micron Boise campus. It's a very nice sunny picture.
Thanks.
We have a lot of new buildings in it, which I like seeing. I always like to see growth in a company that I'm in. All right, so here's just a recap of those same things that were on the poll. The one that I didn't really talk about on the poll was power consumption. So we have different types of chips. So even when you're looking at our DRAM chips that we make, you make ones that have low power consumption and high power consumption for different applications. So the high power consumption is fine in a server room because you don't care how warm it gets compared to a phone. So in the phone, you want the low power DDR memory because then when you put it up to your ear, it's not burning your ear every time you touch it. So that's very important. And it also doesn't use as much of your battery. And everybody knows that cell phone batteries run down faster than we'd like them to. So just in wrapping up, we're just gonna use poll number 4 as questions that might drive additional questions at the end if we haven't received any. So you can fill this out as we continue the wrap up. There's no rush on this one. Just to end the talk, I just want to bring back the fact that really what this talk was about was opening the eyes and the choices in STEM careers to show you that there's more available than just being a doctor or an engineer. Everybody has a different path. You can see I took a very curvy road to get to where I'm at today. Some people come straight out of high school, go straight to college, become an engineer, love it. Some people go straight from high school to a trade school and do that for years. There's not a wrong or a right path in the STEM fields. And then, career changes. I've never made a career change because I hated my job. I've always done it for the fact it rains too much in Oregon, or trying to move somewhere to be closer to family, different options like that. But I've found challenges in every job, no matter what it's been. I walked into pulp and paper, didn't think I'd like it, thought it'd be kind of boring, and found all kinds of things I could do there and make a difference. With pulp and paper, I could make a change and I would feel it in the pulp and paper 20 minutes later. If I make a change on a microchip now, I don't feel it for, you can't see it or tell what happened, sometimes for 45 days to 90 days, which is a little bit more frustrating. So that's all I have, except for one final quote. So this Sally Ride was a individual I admired very much growing up. So this is one of my favorite quotes by her. I'd like to be remembered as someone who is not afraid to do what she wanted to do, and as someone who took risks along the way in order to achieve her goals. So that's just one of my favorite quotes that she put out there. There's a lot of different options out there. I jumped jobs a couple different times. That's always a scary thing to do. But as long as you're determined and you're willing to take that risk, there's a lot of options for that.
We do have 2 questions, Sarah, and I would
Okay.
like to see if we unmute. I have the first one from OMK007. Would you be willing to ask your question? You're asking about Sarah's engineering manager role. So Sarah, as an engineering manager, what do you do? Do you create new products? Do you manage engineers from a certain department? What's unique about being an engineering manager from being an engineer?
Yeah, so in my role as an engineering manager, there's a lot of different types of engineering managers at Micron, but in my role in particular, I manage what's considered the shift first response type team. And so I have 4 different shifts that work 24/7. And so I don't really make products anymore or anything like that or design anything. What I do is it's more of a people-based job. However, I have peers that I work with that are process managers. And so in their role, they still do a minor amount of development and definitely mentoring of development through their engineers that work for them.
Okay. I have a couple questions from Gaurav Bhatnagar. I think you joined us last week, did you? Do you want to ask one of your questions?
Hello. I had a question about your experiences in the Navy. So did you experience any crossover in leadership skills between the Navy and your other jobs? And if you did, how do you think that set you apart from your peers?
I did. So when I was in the Navy, I became a shop supervisor fairly young. And I also did what was considered an inspector job. And so I would inspect other people's work, sign off on it, say for flight and stuff like that. It definitely helped. So every leadership job that I've had, I've learned different lessons. And being a leader young, you learn your lessons a little bit harder sometimes than being one that has matured a little bit more in industry. So it definitely has helped me later on you know, in my career, since I had that experience and I could rely on that when I was applying for different leadership roles. But at some point in each of the jobs I have at, I was in a leadership role at some point in each of those.
Thank you. Next is a question from Saifan. I probably did not just say that correctly, but if you can unmute yourself and ask Sarah your question.
I know you helped in manufacturing of DRAM chips. That's correct, right?
Yes.
Have you ever worked with SRAM chips or even VRAM chips?
I did work on some development work on those years ago, but I haven't done anything in it recently.
Oh, okay. Thank you.
You're welcome.
All right. And the next one we have Barbara Strickland has a question. Barb asked what your favorite job you ever had was.
Oh, so I think my favorite job was still working on the jets on the flight deck. I have a little bit of an adrenaline junkie bone, and so sitting on the flight deck with a jet turning at full power next to you was pretty exciting for me. That being said, it was my favorite job when I was younger. I don't know if I'd still want to be doing that job today, but to date, I think it was still my favorite one.
Awesome. Well, I'm going to end the polling for this last question. Sarah, if you wanted to take a look at the answers here, and this could be kind of our final reflection.
Yeah, so just looking at some of these. So the most interesting and the most impact the world, both of them, microchips was the highest level one. I think when you look at that, you know, you can look at how the careers impacted the world the most. When you talk about the jets I worked on, since they were radar jamming jets, they actually wouldn't put any other fighter jets in the air unless we were able to launch as well, because we could cloak the other jets. So we can make 2 jets look like 10 jets. We can make all the jets just look like one big bright green blur, basically. The pulp and paper one, you know, most people would not consider that a very world impactful job until you've looked at the shelves recently and they're out of toilet paper. So I think that's become slightly more important recently. But yeah, that's not one that necessarily changes life or death. But the microchips, that one definitely has the ability to do that. I mean, you look at the fact that you are going into life-saving devices, computers that crunch an enormous amount of data to help, you know, find the vaccinations, help find other things to change the world, look at different genetic profiles, different things like that. So I would agree that right now that's probably the one with the most impact.
All right. Well, Sarah, maybe if you would mind unsharing, I'm going to share my welcome slide again, just to remind folks that this was Techie Tuesday, and it's a shared project by the Silicon Valley Education Foundation and Micron. Sarah, I really want to thank you for sharing your experience, and thanks to everybody for joining us here today.
Oh, thanks for letting me speak. It was enjoyable.